Hi everybody. Today we're going to have a quick look at diagrams in probability, and there's three different types of diagrams that we typically use. There's a tree diagram, a Venn diagram, and a two-way table. Venn diagrams and two-way tables are closely related in that they show the same information in a different way, whereas a conditional tree diagram has a little bit more information and can be a little bit harder to get the information out of. So we'll start with the Venn diagram and the tree diagram and the two-way table. So in a Venn diagram, we have four regions. This region here, which is the part of A that's not in B. We have the intersection, which is the part that's in both A and B. We have this region here, which is the part that's in B but not in A. And we have the region on the outside, which is the part that's not in A or B. And they all have their individual notations. There's different ways of representing the same information using set notation, so be aware that this isn't the only way that we can represent it, but these are some good descriptions. Some interesting things to note is that the probability of A is not just this bit, it's that plus this, everything in the A circle. The probability of B given A is the part of B that's in A divided by everything that's in A. So this is the part that's in B, that's also in A, that's the intersection of the two regions, and you divide that by the whole A region. If you're looking for A given B, if we're looking for B given A like it says here, similarly, the part of A that's in B is this part, and we divide that by the whole of the B region, which is this plus that. The union of A and B is everything inside here. And similarly, everything not in the region is what's outside, or the equivalent of that statement. If there's no intersection, A and B are mutually exclusive. So there's no part of, there's no intersection between the B and the A event. Two-way tables display the same information in a similar way. If we look at B here, that's this number here, the intersection is that part there, and PA given B is this region here. So this region plus this region gives me PB, that's this column. If we wanted to know this part here, this is the part that's not in A and not in B, is this probability, and look, there it is there. So same information, different ways. If we wanted to find the sum of each of these regions, so sum of that region there is 1, the sum of this region here is 1, sum of this region here is 1, sum of that region there is 1. If we wanted to find the conditional probability, we would just look at B, so that's this column here. What part of that column has A in it? Well, it's just that bit there, so it would be that bit divided by that one. And it's quite an easy one to do conditional probability with, if you understand how the table works. Probably the more difficult of the three is the conditional tree diagram, because it's a little bit more powerful in what it can do, but it's also a little bit more complicated. So we still have event A and event B, and the intersection of A and B is that times that, and that's shown by this here. The intersection of A and not B, so that would be this region here, is that times that, which gives us this, so on and so forth. And we note that in the second tree, this is the probability of getting B given that A occurred before it, and that this is the probability of getting not B given that A occurred before it, designated by those statements there. And to work out the probability, we multiply them together. So if we wanted to find the probability of B, we'd have to look at everywhere where the B events occur, work out the probabilities, and then add them together. And that's what I've said here. If we wanted the intersection, we would need where A intersection B occurs, which is those two events multiplied together. Now the interesting thing about these tables is these two values here will always add to 1, as will these two, as will these two, as will all of these four final outcomes add to 1. Now the most difficult probability to probably find out on a and conditional probability table is A given B. Because to find A given B, we need the probability of the intersection of A and B and the probability of B. Well, the probability of B we worked out earlier was this statement here, that plus that. And the intersection is just that, so we set it up as two different statements and then divide them. And if you consider them in this way, knowing this and this separately, it becomes easier to find out the conditional probability statements for A, where for given B, the given A ones are obvious because they're written on the tree. I hope that helps, and with the exams coming up, that can be useful to know. If I have a bit of time, I'll do some examples that show how that can be used. Thanks, everyone.